You're probably asking yourself this question: when and where will I use statistics? If you read any newspaper, watch television, or use the internet, you will see statistical information. These statistics about There are statistics about crime, sports, education, politics, real estate. And right about now in this country with this coronavirus, it's all you're seeing. And unfortunately, it's a lot of stats about the people that have died, over 100,000, or different states where the amount of coronavirus cases are spreading. It is just all over the place. Statistics, I mean, in today's world. Since you will undoubtedly be given statistical information at some point in your life, you need to know some techniques for analyzing the information thoughtfully. Think about buying a house or managing a budget. Think about your chosen profession. The fields of economics, business, psychology, education, biology, law, computer science, police science, and early childhood development require at least one course in statistics. Included in Chapter 1 are some basic ideas and words of probability and statistics. You will soon understand that statistics and probability work together. In fact, Chapter 4 is where we discuss probability. You will also learn how data are gathered and what are good data and what can be distinguished from bad data. We hear the phrase fake news, and I'm not going to get into people's politics. Whatever you believe in, your politics is your business, just like mine is mine. But in today's society, there's so much statistical data out there. And this course hopes to give you some tools that you can decipher what is good stats and what is some shady stats. All right, so chapter 1, getting started. As in any course, when you first start out, the first chapter, maybe the first two chapters are basic definitions, vocabulary. So we're all speaking the same language, so to speak. Stats is the study of how to collect, organize, analyze, and interpret numerical information from data. Now, the first three chapters sort of focus in on collecting and organizing the data. Chapters 4, 5, and 6, we'll be talking about how we analyze and interpret this information that is gleaned from this data. Take the time. This is a short little video, the importance of stats in different professions. No matter what you're going into, what you're studying. For a future profession, this video kind of touches upon it. It's a short video. Make sure you not kind of, but take the time to actually watch this video. Focus points. Identify variables, distinguish between quantitative and qualitative, identify populations and samples, distinguish between what is called a parameter in a statistic, and determine level of measurements. Now, there is nothing where I ask you verbatim to recite back to me the definition. All right, but as we go through this PowerPoint, even your homework assignments are in the form of a practice test. It's not asking you specifically to write a fill in, it's going to be multiple choice. And as you know, with multiple choice, usually there's two answers that make absolutely no sense and two answers that are close. All right, so you won't be asked to verbatim give you back a definition, but as we proceed through this PowerPoint, you'll have some samples. Decision making, an important aspect of our life. So, yeah, I guess so. We make decisions based upon the information we have, our attitudes, and our values. I don't want to read this entire slide to you because it'll also be posted, but in going through this voiceover, I'll touch upon some important points. Right here in paragraph 3, statistical methods enable us to look at information from a small collection of people or items and make inferences about a larger collection of people or items. If you're interested in public opinion, what the nation thinks about whatever, the coronavirus or who knows, you don't have the time or the money to go in and ask the question or inquire everybody's opinion. So what we're doing is we're taking a small sample, and if we take this sample properly, we can make an inference about what the entire population, let's say, of the United States thinks. If we're interested in what Massasoit thinks, students think about going back in Going back to class, let's say in September, you take a sample, all right, of maybe people taking summer courses, get their views on that. You can extrapolate and say, hey, 40% think it's a good idea, 35, whatever, think it's a little premature. All right. Procedures for analyzing data together with rules of inference are central topics in stats. All right, in each section, you're going to have a video. I call this guy Big Al. All right, he has a way of really breaking things down. Some of these videos, this particular video is only about 17 minutes, but don't sleep on this. Make sure you watch the video. In fact, sometimes you may even want to watch it more than once. He goes through all of the key points that you'll be quizzed or tested on. He has a nice way about him, too, so make sure. I have a folder in Canvas where I have all of these videos listed. So if you ever need to go back and to review them, they're all there, but they'll be in each homework assignment. All right, this is section 111. Please do not sleep on this. Take advantage of it. Here again, stats, another definition, same definition, how to collect, organize, analyze, and interpret. All right, individuals. Individuals, when we do a statistical analysis, are the people or the objects that we're studying. A variable, however, is some characteristic about that individual or object that we're looking at. For instance, here's an example. Say we want to do a study about people who have climbed Mount Everest. Well, the individuals in the study are all the people who actually made it to the summit. In actuality, we looked at this problem before, and we looked at the amount of money it costs to sponsor a trip to climb Mount Everest. I think it's actually decreased now with the coronavirus. I digress. Another variable may be the height of these people who have climbed Mount Everest, all right, their age, their weight, their gender, nationality, income, and so forth. Regardless of the variables we use, we don't include measurements of all or observations from people who have not actually climbed the mountain. Now, these variables, the height, the age, the weight, and so forth, and gender, it could be quantitative or qualitative. Right? Quantitative has a value or a numerical measurement for which operations such as addition and averaging and alike make sense. Qualitative, however, describes an individual by placing that individual into a category or group, such as male or female. Maybe the person is from the United States, maybe they're from China or Russia or whoever. Quantitative numbers, qualitative non-numerical. Here again, you won't be asked per se for a definition, but I'll give you a problem and I'll say, hey, is this information, this data, is it qualitative or is it quantitative? All right, what's the difference between an individual and a variable? Individuals are the people who are included in the study, while a variable is some characteristic that's being measured or observed. Another important source regarding data is their source. Do the data comprise information from all the individuals of interest or just from some individuals? All right, am I sampling everybody of interest or am I just taking a few people or a few different objects? All right, in population data, the data are from every individual of interest. In sample data, the data are only from some individuals. Let me clarify something. When we hear the word population, we often think it's a huge number. It's the population of Brockton, or the population of Massachusetts, or the population of the United States. Doesn't necessarily have to be that. It's the every individual of interest. So, for instance, a population could be our class. If I want to find out the views people have on a particular topic, all right, and if I interview everybody in class, that's my population. However, if I just take the people whose last names begin between A and G, I'm taking a sample. So population doesn't have to be a huge number. It could be just individuals in your household, for instance. As long as you're talking or you're interviewing or getting information from everyone, you have population data. Now, it's important to know whether the data are population data or sample data, obviously. Data from a sample may vary from sample to sample. Let's assume I take the people whose last names begin between A and F and I ask you for your weight. Well, that average weight may be a lot different than the people whose last name begins from L to, let's say, P. All right. Sample data it changes by virtue of the sample, but if I'm taking data from the entire population, well, that's not going to change. That's going to remain constant. Right? Population parameter. Notice how the P's match up. Population and parameter. Population parameter is a numerical measure that describes every aspect of a population. Sample statistic, numerical measure that describes some aspect of a sample. Notice the statistic S and statistic S in sample, P in parameter, and the P in proportion. We all have little tricks how we remember things. All right, little things that help us. Again, what's the difference between a parameter and a stat? A parameter is a numerical measure that describes a population. A statistic is a numerical value that describes a sample. All right, so first question, that's, like a sample test question here. Although there's only two responses most of the time in your exams or your homework problems, there'll be four possible choices, A, B, C, and D. First thing is to read the problem, read the question. A health and fitness club surveys 40 randomly selected members and found that the average weight of those people questioned is 157 pounds. Well, there's this number 157, some numerical information. And the question is, does this 40 represent the entire population of the fitness club, or is it just some of the members? Well, 40 randomly selected people. So they're not interviewing everybody. They just took 40 people that happen to be at the gym, which is, I guess they're opening up now. I'm not sure people are doing much statistical analysis at gyms right now. But the idea is that this is a statistic. Why? Because the 40 is a sample of everyone that goes to this fitness club. It's not everyone. If the problem is that, hey, I interviewed everybody that has a membership at this gym, I don't know how I would do that, but and then that weight, the average weight would become a parameter. It's a statistic because it's based upon 40, which is a sample. Hawaii Department of Tropical Agriculture conducting a study of ready to harvest pineapples. Sounds good. The pineapples are the objects or individuals. The individual weights of the pineapples would be a variable. All right. The pineapples you're actually looking at it, finding some information about the individuals and their weights. This numerical number. This number is a variable. Weights could be measured to the nearest ounce or gram. All right. Weight is a quantitative because it's a numerical measure. Right. If all the weights of all of these pineapples in the field were gathered, then you would have, then all of these pineapples in this field consist of a population. Then the average weight, since it's based on a population, would be known as a parameter. Suppose the researchers also want data on taste. A panel of tasters rates the pineapples according to poor, acceptable, and good. Only some of the pineapples are included in the taste test. Well, that kind of makes sense. I'm not going to take a bite out of every pineapple in the field. It'd be pretty tough to sell these pineapples after. All right, so here's a case where the variable is taste, and it's a qualitative variable. It's not a number. It's either poor, good, or excellent, whatever. Because only some of the pineapples in the field are included. We have a sample, all right? And the proportion of pineapples that have a rating of good would be a statistic. It's because it's based upon a sample. We didn't take a bite out of every pineapple in the field. For a set population, does a parameter ever change? B, if there are three different samples of the same size from a set population, is it possible to get three different values? Well, if the population doesn't change, the values of the parameter aren't going to change. Thus, for a fixed population, the parameters are constant. If we take three samples of different size from a population, the values will always differ. Here again, getting back, if I sampled people from whose last name begin between A and F, and I asked you your average weight, I calculated the average weight would be different from maybe people whose last names begin from whatever, from P to Q, whatever. Data will change sample to sample, but if you have a fixed population, the parameters aren't going to change. All right, so that's some basic things. The crux of this whole section 1-1 is determining what's called levels of measurement. There are four of them: nominal, ordinal, interval, and ratio. The key here is we're going to see that certain examples automatically, as soon as you see it, you say, oh, it falls into the ordinal level of measurement, or you see it's the interval. But by rights, you start out with the lowest level of measurement, nominal. Every data set will meet that criteria. And then you go on. Does it meet the ordinal? If it doesn't, then you stop at nominal. All right. If it meets the ordinal, then you're going to go to the next. Does it qualify for interval? And then finally, if it meets all of the three previous ones, nominal, ordinal, or interval, you're at the ratio level of measurement. All right. Sounds a little foreign, but let me give you some basic examples. We've categorized data as being qualitative numbers or quantitative non-numerical. Another way to classify data is according to one of the four levels of measurement. Basically, these levels of measurement indicate the type of math arithmetic that's appropriate, such as ordering, taking difference, taking ratios, and so forth. So here they are once again. This would probably be a slide that I would incorporate into my notes. Now, along with doing these voiceovers, I'm actually on Canvas going to post the actual PowerPoint. All right. What I would do, I don't necessarily think I don't think you need to print the entire PowerPoint out, but there'll be particular slides that when you're taking an exam, you want to have readily accessible. You're putting all this stuff together. I mean, it'd be nice to have some sort of a notebook and maybe have a divider because you've got a time limit on these exams. Usually they're between 75 minutes, hour and 15 minutes to about an hour and a half. I haven't determined that yet. I'm looking probably a minimum of 75 minutes. So you got to have the answer readily available. You don't have time to go back to a textbook or go online. I mean, you've got X amount of time to complete the exam. So you got to be ready for it. Just as you would if you were doing it in class and I allowed you to use your notes, you'd have all your stuff there ready, accessible to, if you needed it to help you answer the question. All right. I always struggle with these four names of these Indian tribes. So if I mispronounce them, Teos, Acoma, Zuni, and Lord knows what this one with a C ends in, how you pronounce that. Anyways, they're names of four Native American pueblos on the population of names of all Native American pueblos in Arizona and New Mexico. Got it? These names are at the nominal level. Notice that these data values are simply names. By looking at the names alone, we cannot determine if one is greater or less than. Now, I'm not talking about alphabetical order. Just these four names, that's about all I can do. They're labels. It's like saying I'm a Democrat, you're a Republican, or independent. My family was born in Cape Verde Islands. You folks, most of you was born in Ireland. All right, it's just a label. Or I live in Acushnet, you live in Brockton. Place where you live is just a label. You can't do much with that. You can't do anything with it. You can't order that. You can't add or subtract. It's just a label. Right? In a high school graduating class of 319 students, Jim ranked 25th. June was 19th. Walter was 10, and Julia ranked 4th. All right, class ranking. So he says this is at the ordinal level. All right, first of all, if I was presented with this, I would say, yeah, it meets the normal. Everything meets the normal. I can say, hey, Jim had a label of he was 19th, and 25th. June was 19th. Walter was 10th. Now, ordinal implies that I can order these and it makes sense. Obviously, I know that Julia was a higher ranking. She was 4th, Walter was 10th. So I can put Julia first, Walter second, June third, and so forth. All right, Walter ranked higher than June. Jim had the lowest ranking, and Julia had the highest. Only problem with ordinal, numerical differences don't have any meaning. If I'm the 4th in class, maybe my GPA was, 3.56. Then the next person, maybe he or she had a GPA of 3.555. All right. The difference between the rank in class may be very small between the first 10 people, and then you get down to maybe the 40th person and the 50th person. That difference in GPA may be really extreme. It may be, 5/10 of a point. All right. So we can order that, but the difference between the first and the third person ain't going to be the same. GPA is not going to be the same from the person who was 50th and 53rd. You can order it, but differences don't have any meaning. Difference between June and Jim's rank is 6. Same difference between Walter and Julia. However, this difference doesn't really mean anything significant. For instance, if you looked at their GPA, Walter and Julia may have had a large gap between their grade point averages, where Julia and Jim may have had a closer grade point average. In the ranking system, it's only relative standing. Difference between ranks are meaningless. Now, this is one of the ones, this ordinal level of measurement. There are certain things, the minute you see it, go, oh, yeah, that's ordinal. Class ranking, restaurants, good, better, and best, 1 star, 2 star, 3 star, etc. We see things of this nature, bingo, it meets the nominal, because everything meets nominal. And also, it's it satisfies the ordinal data. Class ranking, good, better, and best, 1 star, 2 star, 3 star. All right, next level of measurement. An example would be body temperatures in Celsius, or it could be in Fahrenheit. You can order these. First of all, they meet the nominal level. You can order them, different degree body temperatures. But this falls into the interval level. All right, when we have things temperatures, we see temperatures, bingo, it's the interval level. We can certainly order the data. We can compute meaningful differences. However, Celsius and Fahrenheit temperature don't have a zero starting point. Come November, or I should say, come December and January, when it's 0 degrees Fahrenheit, zero doesn't mean there's no heat at all. It just means it's darn cold. All right. But temperatures don't start at zero. People often say, well, when it's 40 degrees out, it's twice as hot as when it's 20 degrees. No, because there is no zero. The zero doesn't mean anything. Zero doesn't mean the absence of any heat. It's 20 degrees warmer when it's 40 than when it's 20, but it's not twice as much heat. The value 0 degrees centigrade may seem like a starting point. This value does not indicate no heat at all. It just means it's really cold outside. Furthermore, again, it's not correct to say when it's 20 degrees, it's twice as hot. No, it's 10 degrees warmer. Here are examples of, here's another slide that'll be, you'd behoove you to copy this slide or print it out. You see things like temperature, Celsius or Fahrenheit. I notice I don't have Kelvin in there. If you're a science buff, when it's 0 degrees Kelvin, that means there's no heat. All right, so when I talk temperature, I'm talking Celsius and Fahrenheit. I'm not talking Kelvin. Dates in time. Time didn't begin with the year 0. All right, so that's another example of interval. Day of time. There's no 0. Look at your watch. There's nothing that says 0 o'clock. That's another example of interval level of measurement. There is no 0 starting point. Now, time of day is different from length of time. It may take me an hour to drive to Boston. It maybe take me 2 hours to get to Haverhill. That's length of time versus time of day. Notice that in temperature, dates, and time, or time of day, there is no 0 starting point. 0 degrees doesn't mean no heat. Time didn't start with the year 0. And last time I checked, there's no 0 on my watch or my clock on the wall. Lengths, last level of measurement, ratio. Lengths of trout swimming in the Yellowstone River. Okay. Let's say, for instance, I say, all right, I caught a trout. It was 18 inches long. All right. Does it meet the nominal? Yeah, 18 inches is a label that I can apply to this trout. Does it meet the ordinal level? Well, if I caught one that was 18 inches, my buddy caught one that was 20 inches, and somebody else caught one that was 30 inches, yeah, I could put those in order, right? The 18 is the smallest, the 24 the next biggest, and so forth. Does it meet the interval level of measurement? Yeah, there is a 0 starting point, because if I haven't caught a fish, then I've got a trout or whatever that's 0 length, 0 inches long. It meets all the previous three. It falls into the ratio level. By that I mean it's correct to say that an 18-inch trout is 3 times as long as a 16-inch trout. Observe that we can divide 6 into 18 and determine a meaningful ratio. So it met all the previous three. It automatically falls into the ratio level of measurement. All right. Here are 5 different examples. If I was doing this in class, I would have this slide up and I would ask you, the class, for a response. All right. So length of time to compute an exam. Well, it meets the nominal. It meets the interval level of measurement. It can be a label. I can put it, I'm sorry, I can put it in order. One person took 20 minutes, another person took an hour. It meets the interval level. All right, length of time. If you go back to the previous slide, all right, and we know that the length of time, excuse me, I'm a little premature here. Length of time is the interval level. If someone took 30 minutes to do an exam and somebody else took 15, the person who took 30 minutes did it twice, took them twice as long. Ratio level of measurement. Time of class. Well, time of day. That's the interval level of measurement. There is no zero. Your major field of study. I'm a biology major. I'm a math major. It's all you can do. It's a label. I can't order that. If I can't order it, I can't go further up the scale. It's just a label. Poor, acceptable, or good. It's like having 1 star, 2 star, 3 star. All right. That's the ordinal level of measurement. You're scoring on the exam. All right. There could be a zero. So we're at the ratio level of measurement. If someone scored a 75 and somebody else scored a 50, it's 25, the person that scored a 75 did 3 times as better. Ratio level of measurement. Age of student. If someone is 15 and somebody else is 30, obviously the person that's 30 is twice as old. Ratio level of measurement. And there are the correct responses. Salesperson performance, below average, average, above average. It meets the nominal and then it falls into the ordinal. I can't do anything after ordinal. It's like having 1 star, 2 star, 3 star. Price of stock, it's money. You see money, you're talking ratio level of measurement. Names of product, pretty obvious. That's the nominal level. Temperature here again, pretty obvious. The minute I see temperature, it'll be in Fahrenheit or Celsius. It's the interval level of measurement. Gross income, oh, that's money. Money falls into the ratio level. Color of packaging, that's normal. It's just a label. I can't order whether I say the red package is better than the blue package. No, it's just a label. It's the normal level of measurement. And those are your answers. Hopefully this helps. Once again, this is basic. But do yourself a favor. Please don't sleep on watching Big Al. I call him Big Al, the gentleman in the video, because he does a real nice job of reinforcing what I just went through.